Perfect squares. Perfect squares. Keep going. Keep going. What's the pattern? Why are these perfect squares? What's the pattern? Why are these perfect? 16. What's the next one? 1, 4, 9, 16. No. 25. Where? What? No. Where are these perfect squares coming from? Hannah, what do you got? 36. How did she get that? What's the next one? 36. No. 49. Come on, somebody else has got to know the pattern. 1, 4, 9, 16, 25, 36, 49. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. What's the next one? 64. Keep going. We're going all the way up to 144. 81. 100. No, 121. And 144. Those are all perfect squares. Perfect. It's a perfect square. Perfect. Okay? It's a perfect square. If we're doing area, side times side, you would have 6 times 6 gives you 36. It's a perfect square.
This hall,
Yeah.
is a rectangle and not perfect.
Exactly. A rectangle is a non-perfect square. Good one. I love it. Still thinking outside your boxes.
Oh, that was a fun one.
Here is your number system, the real number system. Real. See, fake. Thank you very much. There is such a thing as imaginary numbers. So this whole big box represents real numbers. You would have another box right next to it that is called imaginary numbers, and you don't have to worry about those until Algebra 2. So thank you. You were the first person to catch on. Well, if there's real numbers, are there fake numbers? Yes, they're called imaginary numbers. When you were young and you went 1, 2, they're like, oh. Okay, so that's naturally how you start counting when you're a kid. You don't start with 0. Nobody starts counting with 0. And so the natural numbers are starting at 1 and they go to infinity, which is why I have those dots there. It's going to infinity. So if it has 1 or it has 1,000 or it has 1,000,000, it's in the natural numbers. Notice how these boxes are within each other. That means that the whole numbers would also have the natural numbers in them. But what makes it the whole set? 0. 0 was a very hard concept to understand in the beginning when they were using numbers. They knew that they received nothing, but they didn't know how to represent 0. How do you represent something you can't see? So now we see that the natural numbers are in the whole numbers, and the natural numbers and whole numbers, they are in the integers. That means that we have the whole numbers, we have the natural numbers, the whole numbers, and there's one more thing that's added to this set. Otherwise, it's just the natural numbers. The negative numbers would be in the integers. -1, -2, -3 to infinity on both ends. So positive numbers, negative numbers, and 0 would be in the integers. Notice that the naturals, the wholes, and the integers are all nestled within the rational numbers. That means you're going to have the natural numbers. I'm not going to put the ... on the end yet. You would have 0 to make it the whole set. You would have the negatives to make it the integers. But there's something else that's added to this set. And my question to you would be, what's the root word in rational? Ration was close, shorter. Ratio. Did we not just take a test on ratios?
No.
Ratio. What's a ratio?
Number.
It's a fraction. So here I'm going to put 3.5.
Oh, no.
And if I have fractions, I also have decimals. So I'm also going to put right here, I'm going to put 4.5. And now I'm going to put ... on both ends. So you've got the positives, negatives, zero, fractions, and decimals are all in the rational numbers. We need to talk about decimals. There are 3 kinds of decimals. And I'm going to continue in the box that goes down here that would go with rationals, the big box. So down here, I'm still in the rationals. I want to look down here because I have more to say about the rationals. What kind of decimal is this? There's 3 kinds. What kind is 4.5, 4.5?
Average.
It's called a terminating. That's a terminating decimal. 2 more kinds. We have a terminating decimal that belongs within the rationals. 1 more kind also belongs in the rationals. The 3rd one does not belong there. Exactly. So I'm going to put 0.3 repeating. Repeating decimals. Repeating decimals and terminating decimals, they belong in the rationals. What's the 3rd kind? If it's not terminating and it's not repeating, what is it doing? Huh? Sort of. It is a decimal number that goes to infinity. No patterns, no repeating. And that belongs over here with the irrational numbers. Exactly. Pi is a decimal number that goes on forever and does not repeat. Decimal that doesn't terminate or repeat. Decimal that doesn't terminate or repeat. So pi is definitely the one that most people recognize for irrational numbers. There's 1 more kind that's going to be with irrational numbers, and those are non-perfect squares. Non-perfect squares and pi, and we're going to give some examples of those non-perfect squares. Non-perfect squares, we already know what perfect squares, they're on the other side, 1, 4, 9. So perfect squares would actually go here as well. What is the square root of 4? What times what equals 4? So that means that if I see a perfect square, I have to actually evaluate it and use that number. The square root of 4 equals 2. That means that 2 is in the natural numbers, so the square root of 4 is in the natural numbers. The square root of 4 would be in the whole numbers because it's 2. The square root of 4 would be in the integers because it equals 2, and it's also in the rationals because it equals 2. So every time you see a square root, don't just think it goes in one place or the other. Is it perfect or non-perfect? Because perfect squares belong in the rational numbers. Non-perfect squares would be things that don't work out perfectly, which would be like the square root of 5, the square root of 7, the square root of 11. There are many, many non-perfect squares. 10 is not a perfect square, but it's even. So it's not that they're odd. It's that no number multiplied to itself equals those numbers. Let's look at this real quick. You don't need to do this. I want to explain what it is. And so we're going to be making number lines. And remember, the number line always goes on bottom. Okay, what we're trying to show goes on top. So the square root of 9 is 3 times 3. It equals 3. That's why it would be above the number 3. What's going to go above the number 2? The square root of 4 equals 2. Those are perfect squares. They work out to whole numbers. How about above the 1? Is there a perfect square for 1? 1. How about a perfect square for 0? Exactly. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. All right, so now the non-perfect squares go in between those ones. If I look here, square root of 0 to the square root of 1, there's nothing in there. How about between the square root of 1 and the square root of 4? The square root of 2, the square root of 3, those non-perfect squares are found in between the perfect ones. What would come after the square root of 4? 5, 6, 7, 8. Notice how you're getting more and more non-perfect squares. That's why there's more irrational or non-perfect squares than there are perfect squares. And the further you go out, the more that there's going to be in between them. What does it look like on the left-hand side? How about this? What is the square root of -4? What times what equals -4? What's 2 times 2? That doesn't work. Has to be the same number times itself. Times what? What's -2 times -2? It is also 4. This is an imaginary number. This is what an imaginary number is. You can't do it. Okay, this is different than this number here. This, what's the square root of 4? 2. And then you carry the negative down in front of it. So this is an imaginary. You don't have to worry about these ones. You're not going to see these. But I wanted to explain to you that there's no number times itself that's going to give you a negative answer. But here I could have the square root of -1, because 1 times 1 is 1, and then bring the negative down in front of it. The negative is going to be on the outside. The square root of 4 is 2, and then I have to carry the negative along in front of it. I just wanted to explain to you what that number system looks like. Don't be thinking you're doing it all in one day and that's it. Okay? We'll work at this. This number system is not that difficult, but it might be shocking after vacation to see it. Okay, let's actually see how this works and see how easy it is. There's our number system right there. These are all real numbers. These are all real. Okay, yeah, you guys don't get fake numbers this year. This is the real number system, and the real number system is broken up into rational numbers and irrational numbers. All right, here we go. This is how it works. The square root of 24. Is it a perfect square or a non-perfect square? All you can do is flip over and look at your perfect squares, right? Is 24 a perfect square or a non-perfect square? Where do I start with non-perfect squares then? They're irrational. So they're irrational and they're real. That's it. They're irrational and they're real numbers. So I would go to irrational and real numbers. That's it. They're not anything else. You're not going to find them in rational numbers, integers, or whole numbers. How about the square root of 100? Is it a perfect square or a non-perfect square? What does the square root of 100 equal then? 10. I'm actually looking for the number 10 then. Is 10 in the whole numbers? Yes, the natural numbers are not on here. They don't have them in our book, but I wanted you to know that that actually is the very first set. So they're in the whole numbers because it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to infinity. So they're in the whole numbers. Is 10 going to be in the integers? Yes, 0, 1, 2, 3 again, all the way to positive infinity. 10 is going to be in there. How about the rational numbers? Is 10 in the rational numbers? Once you find where it starts, it started here. It's going to work its way all the way up to real numbers. It's going to be in the wholes, the integers, the rationals, and the real. But listen, once you know where it starts, it's going to work its way all the way up. Let's look at negative square root of 81. Is 81 a perfect square? What's it equal? So what am I really looking for? I'm looking for -9. I got to keep the negative in front of it. So I'm actually looking to see, where does -9 first start? Is -9 in the whole numbers? No. Is -9 in the integers? That means that it's going to be in the integers. It's going to go up to the rationals because rationals have negative numbers, and these are all real numbers. So once it starts, it works its way right up. So it starts in the integers, goes to the rationals, and it's a real number. Okay, -1.5. Is -1.5 in the whole numbers? Is -1.5 in the integers? It has a negative. Why is it no? Exactly. This is where the negatives start. Where do the negative decimals start? They start, very good. Everybody gets tricked on that one, says integers. So the negative decimals start here in the rationals and then continue to the real. There are no decimals in the integers, therefore -1.5 cannot be in the integers. So it starts in the rationals and continues to the reals. All right, get your homework out. 3.2a, the only thing you're not going to be able to do is number 4 and 5.